The world of technology is evolving at an unprecedented pace, driven by innovations like deep learning. This powerful subfield of artificial intelligence is transforming industries from healthcare to finance. Just as deep learning algorithms learn and adapt, we too must cultivate mental strength to thrive in this era of rapid change. This essay explores the fascinating world of deep learning and its parallels with the development of human potential. It's about understanding how machines learn and how we, as humans, can cultivate the mental strength to navigate the challenges and opportunities of the 21st century. Deep learning, inspired by the human brain, enables machines to learn from vast amounts of data. This essay delves into the mechanics of deep learning, explaining neural networks and the training process. We'll uncover the importance of high-quality data and explore powerful algorithms that drive this technology. But this journey isn't just about understanding machines, it's about understanding ourselves. Just as a deep learning model requires resilience and constant optimization, we too need to cultivate these qualities in ourselves. This essay explores the psychology of mental strength, emphasizing self-awareness, a growth mindset, emotional regulation, and discipline. By understanding the principles of deep learning, we gain insights into the power of continuous learning and adaptation. By cultivating mental strength, we equip ourselves with the resilience and tenacity to navigate the complexities of life. Join me as we unlock the power of deep learning and mental strength, empowering ourselves to thrive in this exciting age of technological advancement. Deep learning at its core is about replicating the learning process of the human brain. It uses artificial neural networks, which are complex structures inspired by the network of neurons in our brains. These networks consist of interconnected nodes or neurons organized in layers. Each connection between these neurons has a weight, representing the strength of the connection. These weights are adjusted during the learning process, allowing the network to make accurate predictions. Imagine a neural network trying to identify a picture of a cat. The input layer receives the raw pixel data of the image. This data then flows through hidden layers where complex calculations occur. Each neuron in these hidden layers learns to detect specific features like edges, textures, or shapes. Finally, the output layer combines these learned features to make a prediction, in this case, identifying the image as a cat. The power of deep learning lies in its ability to learn complex patterns from massive datasets. Unlike traditional algorithms that require explicit programming, deep learning models learn these patterns independently through training. This ability to learn from data makes deep learning incredibly versatile, applicable to a wide range of tasks, from image recognition and natural language processing to medical diagnosis and financial forecasting. In essence, deep learning empowers machines to learn like humans, extracting knowledge and insights from the world around them. This ability to process information and make intelligent decisions is revolutionizing countless industries and pushing the boundaries of what's possible with artificial intelligence. Training a deep learning model is like teaching a child to ride a bike. It requires patience, practice, and constant adjustment. The process begins with feeding the model a massive amount of labeled data. This data could be anything: images, text, audio, depending on the task at hand. Think of it like showing the child numerous examples of successful bike riding. Through repeated exposure, the model begins to identify patterns and relationships within the data. Just as the child learns to balance, pedal, and steer, the model adjusts its internal parameters, those weights connecting the neurons, to minimize errors in its predictions. This adjustment process is driven by a powerful algorithm called backpropagation. Imagine the child falling off the bike. They learn from this mistake, adjusting their approach the next time. Similarly, backpropagation calculates the error between the model's prediction and the actual target. It then feeds this error back through the network, tweaking the weights to improve future predictions. This iterative process of feeding data, calculating errors, and adjusting weights continues until the model achieves a desired level of accuracy. It's a journey of continuous improvement, much like our own learning experiences, and just as the child eventually masters riding the bike, the deep learning model, through persistent training, becomes increasingly adept at its designated task. Section 4. The fuel of progress, computational power, and deep learning. Deep learning models are voracious learners, consuming and processing massive datasets to unearth hidden patterns. This data-driven approach requires immense computational power, pushing the limits of traditional computing. Think of it like this. Training a complex deep learning model on a regular computer is like trying to run a marathon while carrying a refrigerator. It's possible, but incredibly slow and inefficient. This is where specialized hardware like graphics processing units or GPUs comes into play. Originally designed for graphics-intensive tasks like gaming, GPUs excel at parallel processing. Unlike CPUs which handle tasks sequentially, GPUs can perform thousands of calculations simultaneously, significantly accelerating the training process. Imagine a team of people working together to build a house. A CPU is like a single worker trying to do everything alone. A GPU is like having a coordinated team of specialized workers, each handling a specific task simultaneously, resulting in much faster construction. This parallel processing power of GPUs has been a game changer for deep learning, enabling researchers and engineers to train increasingly complex models on larger datasets. This, in turn, has led to breakthroughs in areas like natural language processing, computer vision, and drug discovery. As deep learning continues to evolve, the demand for computational power will only grow, driving further innovation in hardware and pushing the boundaries of what's possible with AI. Section 5. The Human Element. Cultivating mental strength for life's challenges. Just as we train deep learning models to adapt and improve, we too must cultivate our own capacity for growth and resilience. This is where mental strength comes in. The ability to navigate challenges, setbacks, and uncertainties with resilience, focus, and optimism. It's about developing the inner fortitude to persevere through difficulties and emerge stronger on the other side. Think of mental strength as the foundation upon which we build our lives. Just as a strong foundation is essential for a stable and resilient structure, mental strength provides the bedrock for navigating life's inevitable storms. The journey begins with self-awareness, understanding our strengths, weaknesses, values, and beliefs. It's about recognizing our own thought patterns, emotional triggers, and behavioral tendencies. With this self-knowledge, we can start to identify areas for growth and develop strategies to overcome personal obstacles. Cultivating mental strength is not about becoming invincible to challenges. It's about developing the inner resources to face adversity with courage, learn from our experiences, and bounce back stronger than before. It's about embracing a growth mindset, believing in our ability to learn and adapt, and viewing challenges as opportunities for growth and self-improvement.